Recently, I played Half-Life 2 after the 20th anniversary update. A legendary game and really interesting developer comments I would recommend. Anyway, I was inspired to try and make the mechanics of the gravity gun in Unity, coding from scratch. If you haven't played Half-Life 2, the gravity gun, or the zero-point energy field manipulator, is a tool/weapon that can be used to lift and launch physical objects. In the game lore, it is used to handle hazardous materials, but in gameplay, it can be used to solve physics puzzles and hurl objects towards enemies at deadly speed. The gravity gun has 3 features: pull, hold, and launch. Pulling will pull the physics object that the gravity gun aims at towards the player. Once the object is close enough, it is grabbed and held in front of the gravity gun. From the hold position, the object can either be dropped or launched forward. You can also launch objects without grabbing or holding them. Objects that are too heavy for the gravity gun cannot be held. They can only be pushed with the launch feature. From these features, we can design a finite state machine for the gravity gun, which we can then use to model our logic in Unity. If you are not familiar with the finite state machines, I won't go into the details here, but to summarize, finite state machine has a fixed set of states, and the machine can transition from one state to another via an input. Our state machine for the gravity gun contains 3 states: idle, pull, and hold. Idle is, unsurprisingly, when the gravity gun does nothing. Pull is when the gravity gun is pulling the aimed objects towards itself. And hold is when the gravity gun is actively holding an object. Our inputs are start pull, stop pull, grab, drop, and launch. These represent the different actions that the gravity gun can do. Start pull transitions idle state to pull state. Stop pull transitions from pull state back to idle state. Grab transitions from pull state to hold. Drop transitions from hold to idle. Launch can both be used when transitioning from hold to idle or just within the idle state. With this design, I went and started a new Unity project. First things first, we need a first-person character movement, so I made a simple component for movement, gravity, and jumping. Next up is the actual gravity gun component, starting with pull and hold logic. Pulling is rather simple, raycasting to find an object that the camera is aiming at, checking that it is a dynamic rigid body and pulling it towards the camera with add force. A simple solution for the hold logic would be to just set the transform position of the held object to be in front of the camera. But these are physics objects and we want them to behave like physics objects. So holding an object with the gravity gun means using forces in the physics engine to keep it in position, by adjusting linear velocity. Doing this also ensures that you cannot move the object through other physics objects. Gravity is disabled when the object is held, so that it is not constantly being pulled down. The object's orientation is also maintained with angular velocity. The relative orientation to the camera is captured when the object is grabbed, and then that relative orientation is maintained when the object is held. Launching is also quite simple. Add force towards the camera's look direction. This does introduce a problem though. If the object we launch has a lightweight mass, it's going to go at a fast speed. The default collision method of physics objects can cause the fast object to pass through other colliders if there is not a single physics frame where a collision happens. So for the small cube here, we need to set the rigid body's collision detection method to continuous dynamic in order to fix this issue. This does have a performance cost, so it's not recommended for slow-moving physics objects. Next, it's time for some programmer art to make our gravity gun. It's beautiful.
What is that? What the fuck?
Then we add some emissive light and a flare, which intensify when the Graviticon is in pull or hold state. And then some particle effects for holding objects. Adding even simple visuals to a game mechanic makes a difference. Suddenly it's much more fun to interact with. I also added a camera shake effect when launching an object to make it feel more impactful. At this point I wanted to experiment with different sized objects and different mass to see how the Graviticon behaves with them. Another problem emerges from here. We are able to pick up any dynamic object, even if it's a big object with a lot of mass. This is easily fixable with an additional if condition. We make a configurable maximum object mass that can be picked up, and compare rigid body mass with that. Next, I added a couple of fantastic sound effects. We now have the basics of the Graviticon complete. But one feature that is missing is fixed orientation. In Half-Life, if you pick some object such as a saw blade, the orientation of the object is fixed to a specific angle. This is used for objects such as weapons, so you can always launch them blade first, or for puzzle objects that need to be oriented in a specific way, like electrical plugs. To implement this in Unity, I created a C# interface called iGravityConObject. This interface contains a property fixed local rotation, which is a nullable vector containing the local Euler rotation that should be used for the object. If it's null, the orientation is not overwritten. The onLaunched method is used to signal the Graviticon object that it has been launched by the Graviticon. We can use this with the component we will be making soon. I then implemented PhysicsBlade component, which implements the Graviticon object interface. The component adds behavior of a blade object, meaning it can stick to a surface when launched from the Graviticon. The fixed local rotation implementation is simple for this. We can just add an angle property that we can modify in the Unity inspector. To make the blade stick to a surface, we simply trigger the rigid body to go to sleep mode, which means physics are not simulated on the object until some external force wakes it up. While the physics collider is touching the surface, the visual representation of the blade does not, so it just looks like it's floating in the air. We can cheat here by just adjusting the position of the dagger model so that it goes inside the surface. We then reset this position when the rigid body wakes up again. At the moment when holding an object, the code directly uses the difference between the current and target position to adjust linear velocity. This makes the object immediately snap into position in a single frame. This is not exactly how the Graviticon works in Half-Life. It does take some time for the object to reach the target position. So I'll add just the code to replicate this. I add a hold grab velocity property to make the movement speed configurable. But this causes the object to have a seizure when it reaches the target point. This is because the velocity will move the object too much once it is close enough to the target. To fix this, I simply use the old method of adjusting velocity based on the difference, when the distance to target is smaller than the hold grab velocity. The velocity is in units per second, so we multiply and divide by fixed delta time accordingly. Note that we are still modifying the linear and angular velocities directly, so the object mass does not matter in these calculations. Now things are looking smooth enough. To demonstrate the next feature, I created this beautiful looking car. I added some wheels to the car with their own rigid bodies and connected them to the car body with hinge joints. This behaves enough like a car. The problem with our gravity gun is, while I cannot pick up the car body itself due to its big mass, I am able to grab the wheels, and thus the car itself. This is obviously not how the gravity gun is supposed to behave, so to fix this, I add another property to iGravityGun object called canGrab. Then I create another component implementation for the interface, simply called DisableGravityGunGrab. As expected, the purpose of this component is to make the object non-grabbable by the gravity gun. Then I change the gravity gun logic to take this property into account. Now we are not able to pick up the car wheels anymore. Next, some more visuals. I add a line renderer visual to add just a little bit more impact on the gravity gun launch. Alright, time to actually do something with the gravity gun. I made a small course where you need to launch a green ball towards a blue target object. Once you hit the blue target, a platform will spawn that allows you to move on to the next challenge. This allowed me to better adjust the feel of the gravity gun. During this, I noticed that the object felt a bit too floaty. I improved this by just doubling the gravity of the world. Then I increased the launch force of the gravity gun to accommodate. I also increased the pull distance for the last challenge, which involved wooden boxes blocking the path to the blue target object. I decided to stop here as the project had already took a bit of time. But one more thing I wanted to do is clean up the code a little bit. There's no practical reason to do this as it's a one-off project, but I like clean code, so I did it anyway. The first bit of code to clean up is the gravity gun visuals, which is the component that takes care of the visual effects and sound effects for the gravity gun. The component is doing many things, so we split the responsibilities into multiple components. Particle effects, line rendering, emissive animation, flare animation, camera shake, and sound effects. I also moved these components to the game objects that they manipulate for better prefab organization in Unity. Next cleanup is moving input and tag constants to a single static class. After this, I was thinking of implementing unit testing next. I was looking at the Unity test framework, but the test framework runs tests in a full edit mode or play mode environment, so it would be more appropriate for integration testing than unit testing. It is possible to create a layer of abstraction between Unity components and game logic, allowing me to run unit tests by mocking the Unity interface. But this is a significant effort, so I will explore that in another video with a different example project. And that's it. I could have continued this project to make a more complete small game, but I was mostly interested in replicating the gravity gun game mechanics only. I will certainly do more small game projects in the future and post them in this channel, and I also plan to make videos about software development in general. So if that's something that interests you, feel free to subscribe. Thanks for watching. Bye.